Hello students, welcome to the CBSE chemistry lecture series. Today we are going to discuss about mole concept in standard 12 chapter some basic concepts of chemistry. Normally in chemistry mole is nothing but amount of substance. Normally, the relative atomic masses of the elements could be determined. However, the problem of finding the absolute masses of the atoms remained unsolved until it became possible to count the number of atoms or molecules in a definite amount of substance. So, this number has been experimentally determined and found to be equal to 6.022137 into 10 to the power of 23. So normally is 7 significant figures. However, the value generally used is what? 6.022 into 10 to the power of 23, called the Avogadro constant or Avogadro number, or denoted by the letter N or sometimes Na. They represents Avogadro number. So generally it is actually a scientist, a great scientist, Amedeo Avogadro, to honor the scientist who is a great pioneer in this field. So they named this number constant as a Avogadro number. Thus, a mole is a chemist unit of counting the particles such as atoms, molecules, particles, ions, protons, electrons, or any this kind of microscopic particles. So mole is generally it is a amount of substance. We can express in what, or we can define in three different ways. What are those different ways? First one, it is an amount of substance equal to gram atomic mass or gram molecular mass. That is one kind of first definition. The another one, it is a amount of substance. Mole is what? Is an amount of substance contains Avogadro number of particles. And third different ways of what definition for mole is what? Suppose if it is a gas, in case of gas, it is a amount of gas which has a volume of 22.4 liters at STP. And normally we can call this what? Molar volume. So thus we can define mole in three different ways, and we will discuss one by one. Yes. Now we will briefly about mole concept. 1 mole is nothing but 1 gram atomic mass, or you can say simply 1 gram atom, or simply you can say Avogadro number of particles. Sometimes 1 mole, if it is a molecule, then you have to say gram molecular mass. Suppose if in case of ionic compounds, one mole containing the Avogadro number of particles, that's 6.022 10 to the power of 23. So our more specifically, mole is denoted by the letter small n, which it means given mass by molar mass. Suppose if we express in terms of formula, n is equal to given mass we can say W, and molar mass we can use capital M. This is for our purpose. At the same time, mole, if you want to find out number of entities, n divided by Avogadro number of particles. This also we can use. Okay, we will discuss few problems using these formulas. Yes, problem for practice. So we are having a three different type of problems. The first type 1, calculation of actual mass of a single atom or molecule. Say for example, we will take the question, calculate the mass an atom of silver, a molecule of carbon dioxide. So this is a question. So how can we solve the problems? First you have to recollect the memories of what? What is the molecular mass of silver atom or atomic mass of silver atom? 1 mole of silver atom, that is 108. Its mass number is 108. Normally we can express as a unified mass, U stands for, but if it is a mass we got to say G, 108 grams. Same thing, 1 mole of silver atom containing Avogadro number of particles. So if you want to find out a mass of one atom, mass of one atom of silver is equal to 108 divided by the Avogadro constant number, that is 6.022 into 10 to the power of 23. When the 23 comes up, it is 10 to the power of minus 23. And simplify this one, 108 divided by 6.022, it will comes about 1.793 into this value. That is the mass of one atom of silver atom. At the same time, the another question is also asked, a molecule of carbon dioxide. So first you got to find out the molecular mass of carbon dioxide. Carbon is 12, oxygen is what, 16, number of atoms is 2. So if we add all these things, we are getting a 12 plus 32, which is equal to 44. So 1 mole of CO2 is nothing but 44 grams. Okay, same thing, 1 mole of CO2, if it is expressed in number of atoms or molecules, you can say 6.022 in 10 to the power of 23 molecules. Suppose if you want to find out the 1 molecule of CO2, 1 molecule of CO2 is nothing but 44 divided by Avogadro constant 6.022 in 10 to the power of 23, which is nothing but 7.307 in 10 to the power of 23 minus 23. When it comes up, it will be minus gram. This is the answer for these two problems. Now we will take another type of problem. Calculation of number of atoms or molecule in a given mass of the substance is the second type. So based on this concept, we will take the problem, how many atoms and molecules of sulfur are present in 64 grams of sulfur. Sulfur is normally octatomic molecules, that is 8 atoms in that one. So first we have to find out the molecular mass. How can you find out the molecular mass? Number of atom is what? 8. 1 atom of atomic mass of what? Sulfur is 32. If you simplify this one, if you multiply these two things, we are getting a 256. If we express in grams, then it's called molar mass. So at the same time, it will containing Avogadro number of particles, that is nothing but 6.022 in 10 to the power of 23 particles or atoms. So now you have to think about, if 256 gram of sulfur containing Avogadro number of particles, 6.022 in 10 to the power of 23. The question is what? 64 gram of sulfur. 64 gram of sulfur containing how much? On doing the cross multiplications, we can find out that one. X is equal to 6.022 in 10 to the power of 23. When you come up 64 divided by 256. So it will be a roughly is what? 1.506 into 10 to the power of 23 molecules are there. Now you have to think about number of atoms. How many number of atoms? So if it is 8 atoms, so you have to 8 into this value, 1.506 into 10 to the power of 23, which is equal to 1.204 8 into 10 to the power of 24 molecules. The question is what? How many atoms or how many atoms? So this is a atoms are there. How many molecules this case? So 8. You have to multiply with it if it is in molecules in this case. Okay. Yes. Now we will discuss the last type of calculation of number of molecules present in a given volume of a gas at STP. Here already we defined molar volume is nothing but 1 mole of gas at STP, 22.4 liters. That you have to remember for working out this type of problems. So here what are the data given here? V1 350 centimeter cube and P1 is 2 atm atmospheric pressure and T1 273 Kelvin. At the same time V2, P2 and T2. So V2 is a question mark. So you have to find out this volume. Calculate the yes. And T2 is again 273 Kelvin, whereas P2 is what? 1 atm. You can use the formula, ideal gas equations. P1 V1 by T1 is equal to P2 V2 by T2. You substitute these values here. So P1 is what? 2 into V1 is what? 350 divided by 273. Correct? Here P2 is what? 1 into V2 we have to find out. T2 is 273. So we have to modify this one. V2 is equal to 2 into 350 by 273 into 273 by 1. You can cancel these things. So there is a 1 mole of what gas is here? Given volume of gas is what? Is ammonia gas we have to find out. So 1 mole of ammonia gas. The volume is what? You have to find out. It's a 700 centimeter cube. Okay. So here we have to find out this is a V2. But at the same time 1 mole of ammonia containing Avogadro number of particles 6.022 in 10 to the power of 23. Avogadro number of particles. If we express in terms of molar volume, 22.4 liters is converted to centimeter cube, 22,400 centimeter cube. That is called what? 1 molar volume. So now you are to think about 22,400 centimeter cube of ammonia gas containing Avogadro number of particles 6.022 10 to the power of 23. 700 centimeter cube is equal to how much? You can do the cross multiplications. So x is equal to 6.022 in 10 to the power of 23 into 700 by 22,400. You cancel these two zeros and simplify it. We are getting a and expressing what scientific notation 1.88 into 10 to the power of 22 molecules. So here the question is what? Calculate the number of molecules present in 350 centimeter cube of ammonia gas at STP. That is what? 273 Kelvin and 2 atmospheric pressure they are asking. So thus we can work out the problem like this. Thank you students. If you have any comments, please mention in the comment box. Thank you students.